The saying, "Necessity is the mother of invention," comes to mind when considering how amazing and brilliant some invention concepts are. But creating one isn't always possible or easy for these reasons. In this video, I'll take a look at 5 examples of projects that were doomed to fail from the beginning, due to the sheer impossibility of it. Number 5. Talos Ironman suit. If you're going to waste taxpayer dollars, you have to at least hand it to the Department of Defense for being ambitious. The Tactical Light Operator suit, or Talos, takes its cue from the Marvel Universe by outfitting a soldier in an 80 million piece of armor, replete with enough high-tech devices and capabilities to make it reminiscent of a sci-fi video game character. In conjunction with SOCOM and DARPA, the Talos suit showed a lot of promise, which included gel-like body armor that hardens instantaneously when it comes into contact with high-velocity projectiles. Unfortunately, bringing the project from theory to application has been a long road, and critics have pointed out a number of obstacles and trade-offs in its design, which make its benefits practically impossible to achieve. Most notably, the suit in its current phase severely limits mobility and is nearly impossible to control with both hands while simultaneously holding a weapon. Again, though, it would be able to track a variety of different problems facing soldiers on the ground, including a thermal regulation system that would prevent them from overheating and would probably reduce casualties and armed conflict. The suit doesn't come cheap. In fact, Congress has voiced its concerns from the onset, especially regarding the cost of even producing one workable prototype. Add that to the hundreds of millions of capital the team expects will be required to finish the project and implement it, and you have to wonder if you're really getting enough bang for your buck. No pun intended. Number 4. Triton Artificial Gill. Another really great idea with a lot of promise. The Triton Artificial Gill was maybe too good to be true. Advertised as a small mobile breathing apparatus, it would have been the next evolution of scuba diving equipment, allowing divers to breathe underwater for upwards of 45 minutes, up to a maximum depth of 15 feet. It wouldn't have to rely on bulky tanks, since it would use special filters that extracted oxygen molecules directly from the water. Unfortunately, amateur scientists quickly debunked the technology as being unfeasible, mostly because it was impossible for enough water to pass fast enough through the filters to produce enough oxygen. Even if such a device were 100% effective and efficient, in order to draw enough oxygen from the surrounding environment, it would have to pump nearly 5 liters through its filters every 15 seconds. A second problem is that you would need somewhere to store the gas, and even though Triton schematics show a compressor, in order to work as advertised, they would have to be better than anything currently on the market. The third and final problem is modulating the amount of oxygen a diver would take in, something that bigger and bulkier breathing systems solved by adding other gases, such as helium or nitrogen. Following a slew of complaints, this led Triton CEO, Saeed Kademi, to cancel and refund the $800,000 Indiegogo campaign. They eventually relaunched a new campaign, pointing out that the Triton used liquid oxygen cartridges in order to work properly. So, while this may be a case of misrepresenting their product rather than an outright scam, it's nevertheless damaged their trust, and it'll probably still be a few decades before we see the sort of consumer technology that makes an independent breathing system feasible for the mass market. Number 3. Fontus. The $300,000 self-filling water bottle. In theory, the concept behind the Fontus water bottle had remarkable real-world applications. Utilizing the properties of latent heat vaporization, it was marketed as being able to produce water simply by being exposed to air and light, effectively making it what is commonly known as a Peltier device. Although geared towards cyclists who could strap the bottle into a carrier and produce water as they biked, the technology would have had humanitarian implications too. And for a mere $160, it was a bargain. After the Indiegogo project accrued over $340,000, however, many people were disheartened to realize the Fontus didn't operate as promised. The YouTube channel, EEV blog, outlined the thermodynamics behind the invention, showing that it would take upwards of 60+ hours to fill under normal circumstances, that the relative humidity needed to produce results had to be upwards of 80 to 90%, and that the actual size of the solar panel needed was several hundred times larger than the iPad-sized panel that came with the Fontus. In theory, the technology behind it is solid, but in order for it to be really effective, it would have had to be implemented on a much larger scale. It seems a shame that so much ignorance even led to it winning awards, including a mention from the James Dyson Foundation, which recognizes young innovators, and subsequently gaining funding from the Austrian Go. Number 2. Laser razor. Hearing about any product with the word laser, and it generally elicits a mixture of suspicion and nerdy excitement. And that was certainly the case for a startup company called Scarp, who began advertising a next-gen razor. It was water-resistant, battery-powered, and yes, used laser technology to reduce an incredibly close shave. However, the actual description of the product used a lot of pseudoscientific jargon, such as using a specific frequency of light to give a close shave. The only problem, Scarp didn't even have a working prototype, and according to scientists, the fiber optics involved could at best cut a single hair at a time, meaning you'd be spending hours in front of the mirror every morning. That didn't stop Scarp from producing a video, which showed the razor cutting 3 hairs on the back of a man's head, but the fact it was never demonstrated doing what it was supposed to do should have been a warning. Nevertheless, they managed to bring in close to $4 million with promises to launch their product in 2016, which of course never carried through and led to Kickstarter banning them. According to Kickstarter, bans can't be undone, so it should have ended there. But soon after, an identical product was relaunched on Indiegogo by the same company and raised another $442,000. This time they promised that 5,000 working prototypes had been made, and that the issue had been in finding the proper diodes and fiber optics necessary. But until you see a 5-star rating on Amazon, it's probably a good idea not to believe everything you see or hear. Fool me once, shame on you. Fool me twice. Number 1. Waterseer. Another device with great potential and an innovative approach to new technology. The Waterseer, like the Fontus, was inspired as a way to help alleviate water shortages. For only $134, the alien-looking device featured a long metal cylinder that was planted 6 feet in the soil, where a condensation chamber at the end would collect water. On the top, a turbine would catch wind and direct air down the cylinder, where the relative difference in air temperature and soil would create a condensation effect. Originally, it was marketed as being able to produce upwards of 11 gallons of fresh water a day, so it's no wonder that many people hopped aboard the Waterseer train. If feasible, it would represent a solution to arid areas plagued by drought, so the humanitarian implications were obvious. During their Indiegogo campaign, they managed to pull in nearly $34,000. However, a close look at the theory and practice revealed that 11 gallons was an extremely ambitious estimate. One avid editor went so far as to do the math, and even in a climate that was incredibly humid, he chose Kuala Lumpur in Malaysia. The relative difference between soil and air temperature hovered somewhere around 8 degrees. This by itself, which was a generous estimate, doesn't necessarily guarantee condensation. Given 100% humid air at 86 degrees Fahrenheit and soil at 30 degrees Fahrenheit, which are ideal circumstances, you get only about 0.5 ounces of water per cubic yard of air pumped. At 50% humidity, you get half of that. Additionally, the device functions on the premise that the relative differences in temperature will be stable. But as warm air is driven down the tube, it would heat up the cylinder and the surrounding soil, a variable that didn't seem to be taken into consideration. That isn't to say that the project, which was designed by students out of UC Berkeley, doesn't have some merit. And perhaps with further research and development might yield something of promise. But for now, the analogy of squeezing water out of rock seems to hold. The only limit to what people will throw their money at seems to be the imagination of those willing to push the envelope, either academically or creatively. Sometimes it pays off, and sometimes it doesn't, and whether or not it will be remembered as a stepping stone to something greater or a complete scam is a judgment best left to history. Can you think of any other expensive projects or inventions that didn't work, or other examples of voice did money in the pursuit of science? Feel free to leave a comment in the section below, and don't forget to subscribe. Thanks for watching.